right, hello. I hope everybody's good. And I've got a little virtual stuff for you guys today. So we're going to do a little bit more with net force today, and then we're going to and then we're going to touch on Newton's first law, and then we're going to touch on Newton's third law today. And this will be your virtual stuff for let's see, for March 9th. And then for B track, this will be your virtual stuff for, actually, we might do this tomorrow. So we'll see, kind of see how that goes. So I'll talk to you guys about that in class. So, yeah, so anyway, let's kind of get at it here. So, all right, now, first off, just a little essential knowledge on this. And, when we talk about net force, up to this point, we've been talking about it qualitatively. But now we want to start talking about it quantitatively too. So as we go through this list of problems, and this is, by the way, this is on page 17 in your packet. As we go through this list of questions on page 17 and 18, we're going to be thinking about these things qualitatively and quantitatively both. Okay, well, what's the difference? Well, let's define that. So if we say, so qualitative. Okay, so qualitative. So this is, this is, so we'll say measuring or comparing based on quality. I know you're not supposed to define a term with a term, but in this case, I feel like it kind of works well. And I'm going to come back down here and just put a few examples down here. So this would be, let's see, here's some examples. So color, let's see, it's, it's tall, it's short. So it's stuff like that, okay? It's pretty. Things like that, okay? So it's what color is it? It's tall, it's short, it's pretty, but there's no numbers on it, okay? We're just, this is just measuring or comparing just based on quality, okay? So just based on quality. Okay, so then we can get to, sorry, I sometimes have a hard time with this camera. There we go, that's better. Okay, so then we can get to quantitative. So quantitative. So this is same thing. So this is measuring or comparing based on, now I'm not going to say quantity, I'm just going to say based on numbers. Okay. And so for quantitative, so we can say that, this would be, like, using numbers. This would be, creating categories which we could graph. All right. So here, let's see. So let's give you an example here, and this is gonna be weird, but I'm gonna give you upside down Mr. Greg face, this part. Okay. So I'll give you an example. One of my favorite words in the English language is onomatopoeia. I don't know if you've ever heard of that word before, but it's a great word, and it's a word, it's a word that sounds like its meaning is like it sounds. Okay, like sizzle and crackle and pop. So it's like such a great word. So if I wanted to qualitatively describe that, then I would say that it's a long word. It's a hard to pronounce word. That's how I would, I guess, qualitatively describe that. If I wanted to quantitatively describe the word, I would probably tell you how many syllables is in it. So let's see here. Onomatopoeia. So it's a 6-syllable word. I don't know about you, but I don't know very many 6-syllable words. That's a long word. So yeah, that would be qualitative versus quantitative. Okay, now back to this. Okay, so I'm going to, now you can see this as you go, but I'm going to just kind of draw this line on down, and then I'm going to come over here to this side too, and I'm going to do the same thing. I'm just going to kind of draw a line in the middle here. And as I go through these questions, we're going to address these things qualitatively, and we're also going to address these things quantitatively. So we're just going to draw free body diagrams. So for number one, a car is traveling on a flat road. It experiences a frictional force to the left that is 5 newtons and an applied force that is also 5 newtons. Okay, so qualitatively, well, let's see here. So we'll draw the free body diagram. So we know we got normal force and gravity because it's on the road. And then we've got applied force and we've got friction force. All right. And we know that those are equal and those are equal and those are equal and those are equal. Okay. So the frictional force is 5 and I went over the line there. Sorry. And then the applied force is also 5. So qualitatively, if I wanted to describe this, I would say all forces are balanced. And then I would maybe say no acceleration. If I wanted to describe this quantitatively, I would say the net force equals, so 5. So the net force equals, it's going to, so actually, so I'll say the vertical net force is 0. Now we don't know numbers on that, but we know that it's 0. And then I'll say that the horizontal net force is 5 minus 5 equals 0. Okay, because remember that we're going to have net force in 2 directions. Okay, so that would be my quantitative explanation. Okay, for number 2, so a car is traveling on a flat road. It's speeding up to the left due to a 6 Newton applied force. Okay, the road applies a frictional force of 2 newtons. So again, so we'll start off, actually here I'll draw the body diagram over here. Okay, so it's a car on a road, so we know that normal force and gravity are going to be equal to each other. Okay, so let's see, speeding up to the left. I don't really care so much about that because they're just going to be, friction and applied force are just going to be opposite. So we've got applied force to the left at 6 newtons, and then we've got friction force to the right at 2 newtons. Okay, so we could say that for our qualitative explanation of this situation, we could say vertical forces. So, and I'm just putting a V in parentheses here. So vertical forces balanced. Okay, and then we'll say horizontal forces unbalanced. And so then we could say acceleration to the left. And then for our quantitative explanation to this, we can say vertical net force is 0. And then we can say horizontal net force, 6 minus 2 equals 4 newtons. So 4 newtons to the left. Okay, so that's going to be that's our quantitative explanation of this situation. Okay, and so now we can come over here and we can do all these. Okay, and so that's what you're going to do. So some of these are a little long-winded, but so like while driving on a flat road, the car in front of you slams on its brakes and you were texting while driving. You rear in the car in front of you. The car in front of you applies a 3 Newton force to your car. Meanwhile, your friend behind you didn't drive the safe distance behind you, doesn't have time to react. Your friend's car applies a 5 Newton force on your car. Analyze the motion of the forces acting on your car. Okay, now you can kind of do this same setup down here. So you start off, draw a free body diagram. Okay, and then after that, here, I'll help you with that. So, of course, we know that we got normal force and gravity. Okay, and they're going to be equal to each other. Okay, so let's see. So the car in front of you is going to hit you with a. Now these are kind of like it's kind of like these forces are like coming this way in on you, but we'll still think about them this way. And again, the directions don't really matter that much. Okay, so we've got applied force one way, and we actually have an applied force in another way. So the first car is hitting you with 3 newtons, and the second one is hitting you with 5 newtons. Okay, so there's your free body diagram. So those are not equal to each other, right? Okay, so now you can say qualitatively what's going on and then quantitatively what's going on. Okay, and so go through and do that. Do number 2. There's a few more examples on the back. There's 6 total. Okay, so that's what you need to do today. And I'll have an answer key for you guys on this, and I will post that. All right. Now, let's see. Next, okay, is Newton's third law. All right. So for Newton's third law, oh, you know what? Actually, I want to back up for just a minute. Nope, never mind. I'll do that in class. Okay, okay, so now this is weird because I'm telling you Newton's third law when we haven't talked about the first law or the second law yet. But that's okay because they're kind of standalone a little bit. And we're going to, in class, the next time I see you, we're going to do something in class for Newton's second law that's going to be a little bit more involved. But yeah, so we'll talk about this Newton's third law stuff today. So this is pretty simple. And basically what it says, and I know you can't, hard to see this from this thing gets blurry, sorry. Okay, but you're looking at this too, probably. So this is on page 18 in your packet. Okay, and it says, oops, it looks like I misnumbered these. Okay, so it says that for every action force, there's an equal but opposite reaction force. And I think I was telling some of you in class the other day that I was listening to Elon Musk talk about his rockets, and someone asked him if you could have an electric rocket in space, and he said, no, 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 no. You can't get past Newton's third law. He said you have to account for Newton's third law. In space, it's a vacuum, and so there's nothing to push off of. Okay, and so that's kind of how you can think about Newton's third law: is every action force there's an equal and opposite reaction force. Okay, so like for example, and I'm going to come down here to this person on the bicycle to kind of like just like I guess further talk about that example. If we think about what we call the action reaction pair here, well, the first one is we have the bike. Okay, so when we think about now, you could think about the person pedaling, but let's not think about that. We kind of because if you look at the arrow here, so we've got the wheel. So actually, here I'm going to change that. Let's say that wheel pushes on road, and then road pushes on the wheel. Okay. So the wheel has to have something to push off on. Okay. And that's kind of what Elon Musk was saying about his rocket. He said you have to use gas. You have to have some type of gas fuel in space because by expelling some of that gas fuel, then that gives you something to push off on in order to further accelerate. So you have to have that to accelerate. Otherwise, you would just be moving at constant velocity. Okay. Which kind of leads us back to Newton's first law. So I guess maybe these are a little bit more, these are a little bit more related. Whereas, Newton's first law would be that Newton's first is that objects in motion stay in motion unless acted on by unbalanced forces. That's Newton's first law. So objects in motion stay in motion unless acted on by unbalanced forces. All right. And so if you don't have anything to push off of, then that's what's going to happen. And so whatever an object's velocity would be in space, it would stay that way. But if there's something to push off of, then there can be acceleration. Okay. Now it's kind of weird though, because when this Newton's third law, for every action force, there's an equal but opposite reaction force. Okay. So that's true, but you have to remember though that, that force, so there's going to be so it might be equal and opposite, but those forces could also be kind of acting in the same direction too. Okay. Now in this first example, so the man pulls on the string and then the string pulls on the man. Okay. So those are the action reaction pair. So in that case, the forces truly are equal and opposite. Okay. Um, so for the second example, so the hand pulls the door and the door pulls the hand. Okay. Well, and you could be saying, well, wait a minute, that doesn't make any sense because if that was the case, if they were equal and opposite, then the door wouldn't move. Well, that's true, but you also have to remember that right here, there are hinges on the door. And so the hinges are machines. And we'll get into that in our next unit, but those are simple machines that they convert force in both magnitude and direction into, well, they convert it. So they can move direction, they can move the magnitude of force. And that's kind of how that works. Okay. So yeah, so go through here and do this, and also I'll have an answer key for this too. And yeah, there you go. So that's so a little bit longer on the video today, but I feel like that's some pretty good explanation. So you're going to be doing well, heck, I guess I'll call this page 17A. Oops. So you're going to be doing page 17. You're going to be doing page 17A, and then you're going to be doing page 18 in class today. All right. So there you go. All right. Hope everybody's good. And yeah, I'll see you all on Thursday.